Hi students, in this video we're going to talk about hydrates. These are special types of ionic compounds, and I want to refer back to our three main rules for naming ionic compounds. Rule 1 was name the cation, which may require a Roman numeral if it's a variably charged ion. Name the anion, and then 3, name the hydrate, and there it is, we're going to talk about hydrates, if it exists, because not all compounds are hydrates. And if it exists, we're going to use the Greek prefixes appropriately. So moving back to this page, we're going to move forward here, now talking about hydrates. So as I mentioned, the third rule for naming ionic compounds deals with hydrates. A hydrate is a special type of ionic compound that has one or more H2O, or water, molecules. Water molecules as part of their crystal structure. They're easy to spot because they have the water molecules added to the end of the ionic formula. For example, here is a formula of a hydrate, and you can see that there is after the cation and the anion, we have a dot in the middle of the line. That's not a period, but a dot. It's raised up a little bit, so it's in the middle of the line. And right after the dot, we have some number of water molecules. Maybe it's only one, in which case we leave the one invisible. But if it's more than one, then we put a number there. So when you see these, it's obvious that you have a hydrate because you have some number of water molecules that are attached to the end of the ionic compound formula. To name the hydrates, we use our standard ionic naming rules, but then add hydrate, the word hydrate, to describe the water molecules that are attached. And we must use Greek prefixes to show how many water molecules there are. So we know the Greek prefixes, so I'll go ahead and write these fairly quickly. Mono for 1, di for 2, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay? So, if we were to name this compound, we would name the cation, then name the anion, and then name the hydrate if it exists, which it does in this case. So, LiNO3 dot 3H2O. So the cation is a lithium cation. That NO3 is a nitrate. And then we use the word hydrate with a Greek prefix to convey how many of those water molecules are part of this formula. So this is a trihydrate. So the name of this compound, LiNO3.3H2O, is lithium nitrate trihydrate. And there we go, lithium nitrate trihydrate. So I would like for you to give this a shot. Here I've given you a compound formula. A, is this an acid? No. B, is it ionic? Yes, it has metal in the first position there. So it's an ionic compound. We're going to use the ionic naming rules, which is you name the cation, name the anion, and name the hydrate if it exists. By the way, this MgSO4.7H2O, that is commonly called Epsom salt, and you may even have some of this at home. So I would like for you to name this compound using our ionic compound naming rules. Pause the video, see if you can name it, and then resume the video when you're done. Okay, coming back to this, we have MgSO4.7H2O. So it's an ionic compound. We're going to follow the three rules. Name the cation, This is magnesium. Do I need to use a Roman numeral here? No. It would be incorrect to use a Roman numeral for magnesium because the magnesium cation is fixed charge. It's always a +2 charge, so I do not use the Roman numeral for its name. Name the anion is the second rule. And SO4 with a 2- charge on it is sulfate. And rule 3, name the hydrate if it exists. Is there a hydrate? In this case, yes. So I use a Greek prefix and then follow it by the word hydrate to indicate that it is a hydrated compound. So the Greek prefix for 7 is hepta, hydrate. So 3 words: magnesium, sulfate, heptahydrate. That is the technical name for Epsom salt, magnesium sulfate heptahydrate.